Hi everyone, I want to go over a couple questions that I assigned from 2.1, from assignment 2.1. Most of them a lot of them are about domain and range, and since we're doing notes on that in class, I'm not going to go over those ones, but I wanted to talk about a couple review problems. So 137, you only have to do A, B, and C, and I want to go over what the question is asking. So in regular graphing calculators, equations must be solved for y equals. So you need all three of these to say y equals in order to type it into a calculator. And that's what they're asking you to do. And then after you're done with that, you're going to type in the original and your new one and see if they match on Desmos. So I'm actually going to do example A for you. So in example A, if we take the equation x equals 3y plus 6, Desmos does allow you to type it in like this. However, a normal graphing calculator would not. You'd have to get y by itself. Y equals mx plus b form. So I'm going to move 6 to the other side by subtracting 6 to the other side. And then I'm going to divide the entire thing by a 3. Now I can type it into Desmos like this, all of it over 3. You just got to make sure this part is in parentheses. Or I can type it into Desmos like this, x over 3, which is the same as 1/3 x. 6 over 3 is 2, so minus 2 equals y. That's much more like y equals mx plus b, but either way is correct. So now what I want you to do is go to Desmos and type in this, and this, and make sure they overlap. Or you can also type in this and make sure they overlap. You're going to do the same thing for B and C. Question 146, it says use any method to find the point of intersection of these two. I would encourage you not to use Desmos till the end. So Desmos should be an easy tool because you type this in and you type this in, you find their point of intersection. However, I want to encourage you to do it the Algebra 1 way. If we want both of these to find out their intersection, really we can replace this f of x with a y and this f of x with a y. And if we want to know where this, in Algebra 1, we call it the equal values method. You set them equal to each other. If you want to know where is their intersection, you're going to set them equal to each other. Now I want you to continue solving this. You can move the 4x over, move the 5 to that side, and you'll get the x value, but don't forget to plug it back into one of these for the y value. Okay, so I want you to try that. I'm not going to do the rest of the problem with you. You guys try it, and then once you get the answer, type both of these into Desmos and double check, is your answer correct? Then you would have used two methods. You would have used the algebra method of solving, and you would have used Desmos graphing. The last problem I want to go over is 148, solving these quadratic equations. Now, if you look at the math notes box, it talks about different ways to solve the quadratic equations. Quadratic formula is always an option. However, I only use it when it cannot be factored. So if you look at A and you can come up with 1 times 15 is 15 and negative 8 on the bottom, if you can come up with the two numbers quickly, then you can factor this really easily. Once you factor, and you don't even have to do factor by grouping because A is 1. So come up with the parentheses, x minus a certain number, x minus another number. I think you can come up with those. But don't forget, you have to then use zero product property. Set this one equal to 0 and set this one equal to 0 and solve. For B, if you try to do the x, 2 times negative 6 is negative 12 with a negative 5 on the bottom, you're not going to be able to come up with two numbers that multiply to make negative 12 but add to make negative 5. So your only option on this question is going to be to do the quadratic formula. That's why I wanted to go over this so that you don't get frustrated thinking, I can't figure this out. You're right, you can't, because 3 times 4 won't work, 2 times 6 won't work, 12 and 1 won't work. So you have to do quadratic formula for this question. Okay, so go ahead and try your best on those problems, and I'm always available in the afternoon sessions. You can shut this down now and get to work.